Download this code from codegive.com, link in the description below. Animation cancelling in ActionScript 3, as 3a detailed tutorial. Animation cancelling is a crucial technique in game development, especially in ActionScript 3, as 3, with Flash, that allows you to interrupt an ongoing animation and transition to a new one smoothly. This leads to more responsive and dynamic gameplay by giving players better control over their characters' actions. Without proper animation cancelling, your game can feel sluggish and unresponsive, as players will have to wait for animations to complete before initiating new commands. This tutorial will explore different approaches to animation cancelling in AS3, covering the fundamental concepts, practical examples, and considerations for optimizing your code. Understanding the need for animation cancelling. Imagine a game where a character is performing a long attack animation. Without animation cancelling, the player would be stuck in that animation until it finishes, even if they want to dodge an incoming attack or perform a different action. This lack of control feels frustrating. Animation cancelling allows the player to immediately interrupt the attack animation and transition to a dodge or another attack, making the gameplay feel more fluid and responsive. 2. Fundamental concepts. Before diving into the code, let's understand the core concepts. Animation clips/states. Your animations are typically divided into separate clips or states, example idle, walk, attack, jump, dodge. Each state represents a distinct action the character can perform. Transitioning between states. The process of smoothly switching from one animation state to another. This is where animation cancelling plays a vital role. Event listeners. We use event listeners to detect user input, keyboard presses, mouse clicks, or game events that trigger the need to cancel an animation. Stopping and restarting animations. The core mechanism involves stopping the current animation and starting a new one based on the player's input or game logic. Considerations for seamless transitions. Abruptly stopping and starting animations can result in jarring transitions. Techniques like fading, blending, or using transitional animations are essential for a smoother experience. 3. Basic animation setup, movie clips and timeline. For this tutorial, we'll assume you are using movie clips in the Flash timeline for your animations. Your character's animations would be created on different frames or layers within the movie clip. 1. Create your movie clip. In the Flash IDE, create a new movie clip symbol, example character MC. 2. Add animation frames/layers. Inside the movie clip, create different frames or layers representing your animation states, idle, walk, attack, etc. 3. Frame labels. Place frame labels on the first frame of each animation sequence, example idle, walk, attack. These labels will be used to control the animation playback. You can do this by selecting the frame and entering the label name in the Properties panel. 4. Basic AS3 control. Place the character MC instance on your main timeline and give it an instance name, example character. 4. Basic animation cancelling with goto and play, and goto and stop. This is the simplest method, using the built-in movie clip methods. Explanation. 1. Import statements. We import the necessary classes, movie clip, keyboard event, and keyboard. 2. Current state variable. Keeps track of the character's current animation state. 3. Init function. Sets up the event listener for keyboard input and starts the initial idle animation. 4. On key down function. Listens for keyboard key presses. Based on the key pressed, it calls the corresponding animation function, attack, dodge, walk, idle. 5. Animation functions, idle, walk, attack, dodge. Each function checks if the character is already in the desired state. If not, it uses goto and play to start the new animation from the beginning. It also updates the current state variable to reflect the change. Limitations of the basic approach asterisk. Asterisk abrupt transitions asterisk goto and play, immediately jumps to the specified frame and starts playing. This can create jarring transitions, especially if the animations are very different. Asterisk no interruption logic asterisk it simply jumps to the new animation without any conditions. You might want to prevent certain animations from being cancelled at specific points. V. Implementing animation cancelling conditions, more control. To overcome the abrupt transitions and gain more control, you can add conditions to your animation cancelling logic. Explanation of the improvements asterisk. 1. Attack frame variable asterisk added to help track which frame the movie clip is on during the attack animation. 2. On enter frame function asterisk added listener that increments the attack frame variable when attack is playing. 3. Dodge function changes asterisk the dodge functionality now checks if the attack animation has been running for at least 30 frames. If it hasn't, then the dodge function is not called and the animation isn't cancelled. This example assumes the attack animation is 60 frames. 6. Adding fading/blending transitions. For smoother animation cancelling, consider adding fading or blending transitions between animation states. This is more complex and typically involves additional libraries like GreenSock, GSAP, or using custom code to manipulate alpha values or other properties over time. Here's a simplified conceptual example using alpha fading. It requires GSAP for easy implementation, but the underlying concept applies to other methods. Explanation of fading asterisk. 1. GreenSock tween light, GSAP requires the GSAP library, tweenmax in this example, for easy tweening. 2. Change animation, function asterisk this function handles the animation transition. 3. Fading out asterisk tweenmax.2, this, 0.2, alpha 0, fades out the current movie clip instance, the character, over 0.2 seconds. The onComplete callback function is executed after the fade out completes. 4. Animation change asterisk inside the onComplete callback, we change the animation state using goto and play, new state, and update the current state. 5. Fading in asterisk tweenmax.2, this, 0.2, alpha 1, fades in the new animation over 0.2 seconds. Important notes about fading asterisk. Asterisk performance asterisk fading is relatively inexpensive, but complex blending techniques, especially with bitmap data, can be performance intensive. Asterisk alternatives asterisk instead of fading the entire movie clip, you could potentially fade in/out specific layers or parts of the character for a more subtle effect. Asterisk easing asterisk experiment with different easing functions, example ease in out instead of the default linear easing, for more natural looking transitions. Asterisk GSAP asterisk GSAP, GreenSock animation platform, is highly recommended for complex animation work in S3. It offers powerful features, optimization, and makes tweening much easier than writing custom code. 7. Using a finite state machine, FSM, for advanced animation control. For more complex games with numerous animation states and intricate transition rules, a finite state machine, FSM, is an excellent architectural pattern. An FSM manages the character's state and determines which animation should be playing at any given time based on input and game conditions. Conceptual FSM implementation asterisk. 1. State class asterisk define an abstract state class with methods like enter state, execute state, and exit state. Two concrete state classes * create concrete classes for each animation state, example idle state, walk state, attack state, dodge state, inheriting from the state class. Each concrete state implements the state-specific logic. 3 State Manager class *. A State Manager class manages the current state and handles transitions between states. It would typically have a Chang state method. Explanation of the FSM*. 1 State class * an abstract class defining the basic structure of a state. The enter state, execute state, and exit state methods provide the logic for entering, executing, and exiting a state, respectively. 2 Concrete state classes, example idle state, walk state, attack state, dodge state. Each class represents a specific animation state. Enter state starts the appropriate animation, example character. Go to and play, idle. Also added the listener for the enter frame event. Execute state contains logic to potentially transition to another state based on player input, timers, or other game conditions. The method needs to be removed upon exiting the state. Exit state stops the animation and removes event listeners. Added trace logic to see if state changes are working correctly. 3 State Manager class Chang state, new state. This is the core method for changing the character's state. It first calls exit state on the current state, if any, then sets the current state to the new state, and finally calls enter state on the new state. This ensures a clean transition. On key down, key press listener function to transition between different states when pressing certain keys. Destroy, used to clean up event listeners and states before exiting the class. 4 Document class, example. Initializes the character MC and the state manager. Calls the destroy function when you are closing the window. Benefits of using an FSM organization clearly separates animation logic into manageable states. Maintainability easier to add, modify, or remove animation states without affecting other parts of the code. Scalability well suited for complex games with numerous animation states and intricate transition rules. Testability easier to test individual states and transitions. 8. Optimization considerations. Event listener management carefully add and remove event listeners to avoid memory leaks and unexpected behavior. Especially with enter_frame listeners, make sure to remove them in the exit state method or whenever the listener is no longer needed. Performance profiling use the Flash IDE's profiler to identify performance bottlenecks in your animation code. Caching cache frequently accessed values to avoid redundant calculations. Bitmap data be cautious when manipulating bitmap data directly, as it can be performance intensive. Object pooling if you create and destroy objects frequently, example particles or temporary visual effects, consider using object pooling to reduce garbage collection overhead. 9. Conclusion. Animation cancelling is an essential technique for creating responsive and engaging gameplay in S3/Flash. By understanding the underlying concepts, implementing conditional cancelling, using transition effects like fading/blending, and potentially leveraging an FSM architecture, you can create a more polished and enjoyable game experience. Remember to profile your code and optimize for performance, especially when dealing with complex animations or visual effects. Experiment with different approaches to find what works best for your specific game project. Good luck! Mastering attack buffer breaking, ABB, in fighting games, A comprehensive guide with code examples. Attack buffer breaking, ABB, also known as attack cancelling or move cancelling, is a fundamental technique in fighting games. It allows players to interrupt the animation of one attack with another, leading to faster, more fluid gameplay and complex combo possibilities. Understanding and implementing ABB is crucial for creating engaging and competitive fighting game experiences. This guide will delve deep into ABB, covering the core concepts, implementation strategies with code examples, using Unity/C as a representative language, and considerations for balancing and design. Understanding the core concepts of ABB. One animation states * in a fighting game, your character transitions through various animation states, such as idle, walk, attack_punch, attack_kick, jump, block, etc. These states define the character's visual representation and behavior. 2 animation events/triggers *. These are points within an animation timeline. They trigger specific actions or functions in your code. For example, an animation event in attack_punch might signal the start of the active hitbox frame. 3 Attack startup, active, and recovery *. Every attack has distinct phases. Startup * the animation frames before the attack's hitbox becomes active. Active * the frames during which the attack's hitbox is active and can connect with the opponent. Recovery * the frames after the active frames, where the character returns to a neutral state. This is the most crucial phase for ABB. For the attack buffer * a small time window, typically measured in frames, in which the game remembers player input, example pressing the punch button, during the recovery of the previous attack. If a valid input is received within this window, the game will immediately transition to the corresponding attack. 5 Cancel windows * the specific frames within the recovery animation where cancelling into another attack is allowed. Not all recovery frames are cancelable. This is usually defined by a configurable window or even a list of specific frames. 2. Implementing ABB, a step-by-step approach with code examples, Unity/C. We'll create a simple character controller with 2 attacks, punch and kick. The punch animation can be cancelled into kick during a specific portion of its recovery. 1. Setting up the character and animations ***. Create a Unity project and a new scene. Import or create a character model. Animate the character with the following animations. Idle. Walk. Punch. Kick. Create an animator controller for the character. Create states for each animation in the animator controller and connect them logically, example idle-punch-idle. Add parameters to the animator controller. Is punching, boolean. Is kicking, boolean. Is moving, boolean, for walking, etc. 2. The character controller script, attack buffer controller.cs. Explanation ***. Animator *** a reference to the character's animator component. Move speed *** the character's movement speed. Punch startup frames, punch active frames, punch recovery frames, kick startup frames, kick active frames, kick recovery frames **. These variables define the timing properties of the punch and kick attacks respectively. You will need to adjust them based on your animation. Attack buffer window ** the duration, in seconds, of the attack buffer. Inputs within this window will be stored. Cancel window start, cancel window end *. These variables determine the start and end of the cancel window as a percentage of the attack's recovery. This defines which part of the recovery can be cancelled. Asterisk current attack timer asterisk a timer to track the progress of the current attack. Asterisk is attacking asterisk a Boolean flag indicating whether the character is currently attacking. Asterisk cancel asterisk a Boolean flag indicating whether the current attack is in a cancelable state. Asterisk current attack asterisk a string variable storing the name of the current attack, punch or kick. Asterisk buffered attack timer asterisk timer to track buffered attack. Asterisk buffered attack asterisk string that will store the name of the attack to buffer, punch or kick. Asterisk start, asterisk gets the animator component and handles potential errors. Asterisk update, asterisk. Asterisk handles character movement. Asterisk checks for punch and kick button presses. Asterisk updates the current attack timer if an attack is in progress. Asterisk checks for the cancel window. Asterisk checks if the attack should be finished or interrupted. Asterisk buffer attack, string attack name, asterisk handles buffering of attacks, storing them and setting the timer. Asterisk try to start buffered attack, asterisk checks if we should try to start a buffered attack. Asterisk start attack, string attack name, asterisk initiates the attack by setting the appropriate animation parameters and resetting the current attack timer. Asterisk interrupt attack, string attack name, asterisk cancels the current attack and immediately starts the new attack, only called if cancel is true. Asterisk finish attack, asterisk resets all attack related variables and animation parameters. Asterisk is in cancel window, asterisk returns true if the current attack is within its cancel window. 3. Setting up input asterisk asterisk. Asterisk in Unity, go to Edit-Project Settings-Input Manager. Asterisk create new input axis. Asterisk punch asterisk set positive button to your desired punch button, example J. Asterisk kick asterisk set positive button to your desired kick button, example K. Asterisk horizontal, already present. Used for left/right movement. 4. Configure the animator controller asterisk asterisk. Asterisk add transitions between idle, punch, and kick. Asterisk create transitions from punch to kick, and vice versa, with conditions based on is punching and is kicking parameters. Asterisk make sure has exit time is unchecked on the transition from punch to kick, and any other cancelling transitions. This allows for immediate transition when the conditions are met. Asterisk adjust the transition duration to 0 for instant transitions. This is crucial for ABB. 5. Attach the script asterisk asterisk. Asterisk add the attack buffer controller.cs script to your character game object. Asterisk drag the animator component from the character onto the animator field in the inspector for the script. 3. Refining and extending the ABB system. 1 Animation events asterisk instead of calculating cancel windows based on frame counts in update, you can use animation events to trigger set can cancel, bool value, directly from the animation timeline. This is a more accurate and maintainable approach. Asterisk in the Unity animation window, scrub to the frame where the cancel window begins in the punch animation. Asterisk add an animation event to that frame. Asterisk set the function to call to set can cancel, true. Asterisk add another animation event where the cancel window ends and call set can cancel, false. 2 Cancelable state machine asterisk for more complex games with many attacks and cancel options, you might want to implement a dedicated cancelable state machine that manages allowed transitions between attack states. 3 Prioritizing attacks asterisk implement attack priority. If 2 attacks are buffered at the same time, determine which one should be executed based on predefined priorities, Example: a special move cancels a light attack. 4 conditional cancels * implement cancels that depend on hit/block. For example, only allow canceling into a special move if the previous attack hit the opponent, opening up more strategic combo possibilities. 4. Balancing considerations. Recovery frames the length of the recovery animation significantly impacts the game's pace and combo potential. Shorter recovery allows for more aggressive play, while longer recovery encourages more cautious strategies. Cancel window size the size and position of the cancel window control the difficulty of executing cancels. Smaller windows require more precise timing, while larger windows make cancels more forgiving. Attack buffer window a larger buffer window makes cancels and combos easier to perform, while a smaller window demands stricter timing. A good starting point is usually between 0.15 and 0.3 seconds. Animation speed and frame data, startup, active, recovery, should be carefully considered in relation to the attack buffer and cancel window to ensure balanced gameplay. Best practices. Use animation events. Animation events provide the most precise and maintainable way to define cancel windows and trigger actions within animations. Avoid hard-coding frame counts in update, whenever possible. Modular design. Create a modular architecture that allows you to easily add new attacks and cancel options without modifying existing code. Consider using interfaces or abstract classes to define common attack behaviors. Data-driven approach. Store attack properties, startup, active, recovery, cancel windows, in data files, example JSON, or scriptable objects in Unity, so you can easily adjust them without recompiling the code. Thorough testing. Test your ABB system extensively to ensure it functions correctly under various conditions and does not lead to unintended exploits or imbalances. 6. Advanced techniques. Frame perfect cancels. Implement cancels that require extremely precise timing, often within a single frame. These add a high skill ceiling to your game. Just frame inputs. Similar to frame perfect cancels, these require precise input at a specific frame to trigger a special version of an attack. Roman cancels. Guilty Gear, a mechanic where you can expend a resource, like meter, to cancel almost any animation at any point, opening up massive combo possibilities and complex decision-making. Fast recovery. A feature where certain actions, example blocking at the right time, can significantly reduce the recovery time of an attack, allowing for faster follow-ups. 7. Complete example code, with animation events and data-driven approach. This example uses scriptable objects to store attack data and animation events to manage the cancel window. 1. AttackData.cs, scriptable object. 2. AttackBufferController.cs, modified. 3. Setting up the scriptable objects. Create two scriptable object assets by right-clicking in the project window and selecting Create-Fighting Game-Attack Data. Name them Punch Attack Data and Kick Attack Data. In the inspector, set the attack name, startup frames, active frames, recovery frames, cancel window start, and cancel window end values for each attack. 4. Attaching the script and scriptable objects. Add the attack buffer controller.cs script to your character game object. Drag the animator component from the character onto the animator field in the inspector for the script. Drag the punch attack data and kick attack data assets onto the punch attack data and kick attack data fields, respectively, in the inspector. 5. Setting up animation events asterisk asterisk. Asterisk open the punch and kick animations in the animation window. Asterisk for each animation, scrub to the frame where you want the cancel window to start. Asterisk add an animation event to that frame. Select the attack buffer controller script in the inspector and choose the set can cancel, bool, function. Set the argument to true. Asterisk scrub to the frame where you want the cancel window to end. Asterisk add another animation event and call set can cancel, false, at that frame. This setup provides a much cleaner, more organized, and data-driven approach to implementing ABB, making it easier to manage and adjust your game's combat system. By understanding these concepts and implementing the techniques described in this guide, you'll be well equipped to create a dynamic and engaging fighting game with robust attack buffer breaking mechanics. Remember that iteration and experimentation are key to finding the right balance for your game's combat system. Good luck.